Hello, friends. My name is Anton Kanuk, and together with Greg Hankins from Nokia, we'll speak today about some topic that probably one of the most discussed these days in the front of introduction of the SDN and programmability and something like this. So, hello, Greg.
Hello, my name is Greg Hankins. Thanks for having me, Anton.
So yeah, together with Greg, we'll discuss this topic. So let's, what do you think, Greg, when people speak about the programmability, what is it in general? What do you think?
So I think in the industry over the past, maybe starting as early as 5 years ago, there's been a big focus on automation and programmability. And this is really to take the human error and to take the reduce provisioning and operations time out of configuring the network. So I think that's really what automation is all about, is programmability and visibility. And there are a couple new technologies that have been introduced to the market that make this a lot easier now.
Okay, yeah, that sounds interesting. And that is exactly the point why I would like to have you for this perfect session, because I know you well. I mean, you're great at product manager from the Nokia, but the people who might don't know you, that is why we're having Greg here. So Greg is a senior product manager. He's working with the development of the Nokia products, so SROS, and from different areas in programmability, and the model-driven stuff is one of his major tasks. Greg was presenting on various events, and he's taking part in NANOC or peering database different ways. He also authored a couple of RFCs that is quite new, let's say, quite fresh-baked. Yeah. He's working quite a lot in this area, and this is a LinkedIn profile, so afterwards you could just follow for Greg for his postings. Okay, let's move further. So, Greg, what is model-driven? Why it is model-driven?
So when we talk about model-driven configuration, it relies on a data modeling language to define the configuration parameters. So in our case, it's based on Yang. Yang is a data modeling language. If you ever work with SNMP, you know that SNMP uses SMIV2 as the modeling language. And it's not particularly good or really fun to read. So Yang is a better modeling language that's easy for humans to read and also provides much more flexibility than what we had with SNMP in how you define the model and how you build constraints into the model. So it's a much better language for modeling configuration. Huh? And then on top of the data models, we have protocols or interfaces that use these Yang models, and each of those have a particular transport and a particular encoding. So NETCONF, for example, runs over SSH, and it uses XML for its encoding on how it encodes the Yang model. gRPC, for example, uses JSON encoding over HTTP. So it's really a flexibility in your choice of how the encoding works versus how the model is done.
Okay, thanks. That's a very important topic, because in a lot of conferences, in a lot of presentation, NetConf always come in /Yan. But what you are saying is NetConf and Yan is different things, and Yan could be used with other transport protocols. Is it correct?
Yeah, exactly. Yang is just the data model. I think people associate NetConf and Yang together because NetConf was one of the first, or I think possibly the first, RPC or protocol that use NetConf. So they're often put together, but they're really an abstraction, and they don't necessarily have to go together. So I think you have a good representation here with the dotted line that the data model is separate from the protocol that actually uses that model. And in our case, we've redesigned our CLI to be based on the Yang models as well. So each interface that you use is just a rendering of the Yang model in that particular format. So XML, for example, or JSON, or in our CLI, we have a hierarchical output. So it's all based on the data model. It's just an abstraction and a representation of how you view that data model.
Yeah, and that is very good, actually, I think, movement from the Nokia, because as being a customer, of being the guy who is working with the CLI and trying to manage the devices in a consistent way, having this model-driven CLI really makes the life easier, because I could try all the configurations, I mean, model-driven YAN models directly in CLI, not only necessary of having their NetConf or RESTCONF interfaces up and running.
Yeah, and that's a big advantage of the consistency that you get when you have a model-driven configuration. You know, I always like to use the example of SNMP. With SNMP, you have some sort of OID that's either a string or a set of numbers, and you have no idea how that maps to the actual configuration parameter. And I think it's very frustrating, very difficult to build provisioning systems over SNMP. But with a model-driven configuration where you have a proper data modeling language, you get a lot of consistency, and so it's a lot easier to build the automation and not only verify the automation, because as you can see in the picture, all of the interfaces are sending the exact same thing. It's very easy to map your configuration that's done over automation to what you actually see in the CLI. It just corresponds one-to-one.
Yeah, that is true. So let's move further. We have spoken right now about the model-driven configuration, so what is good, but we had a lot history, I mean, great history of the CLI-based or SNMP, as you already mentioned, and all this stuff. So if we put these two things together, trying to put, I mean, what is the main difference from how we were doing things previously and how we're doing things now?
So in the classic CLI, the configuration really was based on the SNMP MIB. And so that was very, as we talked about a few minutes ago, that was very constrained because the SMI language is not a particularly good language to model configuration. So that gave us some limitations in the way that the configuration could be modeled. But now that we have a proper data model, as we mentioned, that's based on Yang, that opens up a lot more possibilities to introduce constraints into the model so that you have a lot more opportunity to define an exact configuration. The model tells you the correct configuration, versus with SNMP or the classic CLI, it's just a string of commands and it doesn't have any context. You don't know the correct thing to send. So in the Yang models, for example, there are certain ranges, there are some defaults that are defined, and there are different constraint statements that you have, like a choice. So with SNMP, it's just a set of OIDs. You don't know how they relate. In the Yang model, for certain parameters, for example, they're mutually exclusive. So you have a choice of either setting one parameter or the other. Since we have a data model that can define that structure, you know when you're looking at the model what the valid combinations are. So you don't have to rely on trial and error, or you don't have to rely on the application to tell you when there's an error. You can know that much more farther in advance. So that's a big advantage of model-driven configuration.
Yeah, that sounds really great. And we're thinking about automation, because, you know, everybody's speaking about automation right now. It's coming, I don't know, probably on each and every, even small or big automation. How do you think this model-driven things helping by automation?
Everyone is talking about automation. You're absolutely right. When I talk to customers, there's literally not one customer that is ignoring automation. So every customer that I talk to, from big service providers, mobile operators, hosting companies, they're all looking at automation. In terms of how it's going to play out, I think the maturity for all the tools and the protocols is really good now. As we're talking about before, NetConf was developed, I think, over 5 years ago, maybe as close as 10 years ago. So I think a lot of the bugs and the kinks in the system have been worked out. The standards are mature, and the protocols are mature, and also the tools are mature. The tools are a big part of it, a part of the ecosystem. And you have some tools here. For example, Ansible is very popular, but there's also a ton of open source tools on GitHub that can integrate with automation. So it really gives you a lot more choices. Before, you had SNMP or the CLI, and that's all you really had to automate. So not much choice there either. And there are also a lot of tools to convert different formats. And this is important because different tools use different templating formats. So for example, you might have a Jinja 2 template that needs to be converted into XML for NetConf. So all those tools exist to convert, because once you have a structured modeling language, you can basically convert it into anything that you want. So the real advantage is having that model defined for the configuration, and then you can do anything you want from there, really.
Yeah, that sounds really interesting, because automation means make things quicker, make things easier, and make things simpler. And if we really could have a single model for all kind of connectivity to the network element and managing, that definitely makes the life simpler for all the customers. So if we put together, yeah. So would you recommend for everybody trying to go to the model-driven model or stay in the old ways? And what actually you at the Nokia, I know you have some ideas how to gradually migrate from a classical way to the model one.
Yeah, so in our particular case, we've had the classic CLI and SNMP since the router first shipped almost 20 years ago. So what we did is we started modeling all the configuration in state in Yang, as we talked about before. And we're providing a gradual transition mechanism where we realize that customers have hours, hundreds of hours, thousands of hours sometimes invested in training. They have many different systems for provisioning and billing and accounting and all those kind of things. So we knew that in order to effectively transition to model-driven configuration, we had to provide some sort of easy way to do that. So in our case, we can use the classic interfaces in addition, in parallel to the model-driven interfaces. So you can use all of your existing tools to manage the router that you've already deployed, and then you can gradually transition to NetConf, for example, or gradually transition to gRPC if you're investigating telemetry, for example. So that was really important for us to provide a transition mechanism because, as I said, customers have so much time invested in the classic interfaces, and it's going to take some customers, and we have some large customers that have tens of management systems. So you can imagine it's going to take them many years to transition. So that was one of our big goals, is to make that transition as easy as possible so that they can just migrate one piece at a time, and they don't have to have a day where they turn off all their existing systems and then turn on the new system. It's not practical.
And I think that is very good, because if you know something old, something you, let's say, used to work for a lot of years, and you need to completely change the way how you are doing things, so such migration, also taking into account the integration, it's not that easy. But having possibility to make it step by step, yes. What do you think? I mean, the last probably point is a general concept of a network as a code approach. Would it fly for all the industry, or is it specific more for data centers, or is it applicable also for service provider, for enterprises? What do you think?
So I think I think this is an interesting concept, and I think we're really just in the beginning of what we'll see. I think it started out in the data center, maybe because Ansible and tools like automation deployment tools like Chef and Puppet and Ansible were really popular with the server teams, and they were used to using those kind of tools for deployment. I don't think we've seen it so much in edge and core routing yet, but I think possibly we could get there. And then, the thing is that while we do have a lot of mature standards and mature tools, we're really just at the beginning of automation in terms of what we can do. So right now, the automation is really focused on configuration and state, but there is lots of research going on into trying to verify and validate the configuration. So for example, with NetConf, we know that we can send a syntactically correct configuration, but the big question is, does it do what you want? And does the network work correctly? So that's where a lot of the research is. And I think it's very interesting to say, okay, we have this configuration and we have these constraints about what we want the network to do, then analyze the configuration and figure out if the configuration is correct. So I think that's the next step in automation And there's lots of research out there. I think this is a really interesting topic that we'll see a lot more from in the future.
Okay, that sounds really inspiring in terms of hopefully we will also see all this kind of programmability out of data centers world as well. So,
for sure.
Greg, many thanks for your time today. It was a pleasure to talk to you. It was a very interesting discussion. I hope the guys who will look this video out will also understand more why it is important to go for programmability, why this model-driven stuff really matters. And
exactly.
Yeah, just a small hint, if you like to learn more about the Nokia products, you could visit the Server Experts, where a lot of people from the Nokia will be explaining the details, how things are working there. Thank you very much again. Thank you for your time, and see you next time.
Okay, thanks, Anton. Talk to you soon.
Take care. Bye-bye.